Okay, fine. So let's start. Sorry for the delay. Let me share my screen. In the last session, so we saw that, so how to work with data sharing, right? So we saw the difference. So when we going to implement data sharing, right? So when it is coming to the account to account, one account to another account, then we have to go for data sharing. So this sharing, so we can able to do it by table or view, whatever it may be. Once it is shared, so we need to remember one thing: the shared account can able to access only, it means it's only read only account, right? And at the same time, one more thing, so when you are working with this particular data share, when you created a data share, the shared account can access read only, and they cannot able to create any table. They cannot able to clone also, just for read only purpose. The what is the difference between, so within the account and then other account
Excuse
sharing
me,
is
I cannot hear anything. Is anybody able to hear in the class?
Yeah, I
uh,
can hear.
just a
Yes,
minute.
yes, I can hear.
Could you please check your um, so who is this? I think Priya, is that you? Could you please check your audio settings once? Just a minute. It's clear to everyone, it seems. Could you please rejoin, or you
Yeah,
can
I got
check
it. I
your audio
got it.
setting?
It's my mistake. Yeah.
Okay,
Thank
fine.
you.
Thank you. I think everyone can able to view my screen also, right? Okay. So now, okay. So today, so what we are going to do is we are going to discuss about data sampling. Okay. So before coming to the data sampling, so we need to understand what is data sampling here. Generally, okay, this is so most used for reporting purpose. Reporting purpose. So what is the main intention of like so here, so we are storing the data in a Snowflake. So finally, so we will give this particular data to the reporting purpose to generate reports, right? So before giving the access to complete tables, if you observe here, so there are huge volume of the tables here. So huge data here available in some of the tables in the sample data. If you observe, some of the tables will have some terabytes. Let me show you here. Yeah, you can able to see that. See this one. So around, so 280 GB data, around so 37 GB data we have, around 1.7 terabyte of the data here, right? So let's assume that. So we need to give this particular table, so for to generate a reports, so for the reporting purpose. Then what they will do, if they want to generate any query on this particular thing, so like they need to implement a where conditions, or they need to implement some other joins or whatever it may be, then so on huge volume of data, to execute any query, it will take some time, right? When they are executing the queries on this huge volume of the data, what will happen here? If you observe the hour, the processing cost will be increased because of the warehouse utilization, right? So instead of giving the complete access to the table, so initially what we will do is, so instead of taking the complete data, they will create a sample data. They will create sample data. Instead of accessing all the data, we will first pick the sample data, and then they will build a query on the sample data first. If the query is 100% like accurate, whatever they are expecting, then they will give access to the full table, and they will perform so that particular query on that the full table. So it's like same thing, like for example, I will give you with example, then it will be very clear for us why sampling is required. Let's assume that this, okay, um, the perfect sample they need to take. So when they are building any query, perfect sample means it has to consider all the scenarios. Let's assume that in this, so COVID situations, if any organization, if any like so medical, the company is coming, and then if they are so coming with a like a vaccine, the government organization will not accept blindly, right? What they will ask is, can you give me the samples, so data, right? So your samples data, so whatever the thing is you have tested, right? So let's assume that if they have given the samples for only the age in between 20 to 30 years samples, so all the data, all the samples, whatever the COVID samples they have tested, they tested only in between 20 to 30 years, then is it a valid sample? We cannot consider this is a valid sample, right? Then, so let's assume that they have tested in between 50 to 70 years age, then this is also not valid sample. Then what is the valid sample here? So it has to consider from 1 year to 100 years. So maximum they have to cover all the age groups, right? All the age groups, this is nothing but so all the possibilities, right? So when any organization is tested their samples in between these age groups, then only they can consider that is a valid sample, right? Valid sample. The same way, when you are creating a small set of data from any table, if you observe here, we have a huge volume of the data here, and so all these tables are huge volume of the data. When you are creating a sample data from these tables, it has to consider all the possible scenarios from this particular table. It means when you take a sample from this table, like less volume of the data for the testing purpose, it has to so consider all the probabilities in the data. It means if you pick only first 100 records, it is not a valid, right? Or if you pick so only the first 10,000 records, or first 1,000 records, or if you pick last 10,000 records, or if you pick in between middle, so 10,000 records, this is not a valid sample, because it has to consider so all the data, all the possibilities. Maybe in the first 100 records some data will be there, in the last 100 records some data will be there, in middle, in between also you will have a some data. It means you need to consider all the probabilities in your data set. That is valid sample, you can say that. You can relate it to with this scenario. So when you want to give the valid sample, so we have some approaches in our Snowflake to create a valid sample. No need to do anything, just we need to create, we need to give the keywords. So sampling keywords, those are two types of samplings we have. So let me come to this. If you observe, see this one. So we have, let's assume that we have a huge volume of the data. From this, so we need to create a sample data. So when you are creating a sample data, we have two methods. So one is so Bernoulli method, or so we can call it as a system method. Another method is we have so method, so that is for, so far so based on the rows. Another one is based on the partitions. Which one we have to use? You can use any one of the method so to create a sample. So now when you come to this, okay, this is the example. So what is the COVID example I have taken to easily understand so why we require a sample data, what is the main intention behind a sample. So and When it is coming to Bernoulli method, so R, so we can call it as a, this one is a row method also. So here we are going to mention when we are creating a sampling by using Bernoulli method, so our row method, what it will do is, so based on number of rows, how many rows we have there in a table. So in this particular table, so how many records we have, these may, so if you observe here, around 9 crores 91 lakhs so records we have here, right? In this number of rows, it is going to pick, based on number of rows, it is going to create a sample data. And so this is called Bernoulli method or row method. Here we are going to mention probability when we are creating a sampling. It means, for example, if you mention, so probability 3, it is going to pick 3% of the data from your actual data. If you mention 50%, sorry, 50, then it is going to take, so 50% of data from your actual data. If you mention 100 here, it is going to pick all the 100% of the records. It means the full set of data it is going to pick. So here we are mentioning probability. I will show you. So how we are going to mention the probability when you are creating this some method. So and so this is row method. Another thing is based on number of partitions. This is system method or block method. So when any data it is storing in Snowflake, how it will store? It will create this particular data in number of partitions. It is going to create a based on number of partitions in the backend. From each partition, it is going to pick the data. When you mention block method or system method, here also we are going to mention the probability as well. So when you are mentioning probability, it is going to pick from each micro partition. It is going to pick from the each micro partition. So it is going to pick the sample data and then it will give you. So and which method we have to use, whether it is a system method or whether it is a Bernoulli method, it depends on the volume of the data. If it is a huge volume of the data, then we can go for a system method. If you have less volume of the data, we can go for Bernoulli method. So both will create a same samples, and then so based on the so probability what we are going to give. So let's see that. So how we can able to create a sample. So now just a minute here, simple example. Let's create a table here. Now already, if you observe, so we will take this weather. So this is the schema. So this particular thing, so previously, so from the sample data, let's take this particular schema and then this particular table. So around we have 37.5 GB. Let's take this one, same table name. Then we will give this schema. Previously this schema is available. So now the instead of this schema, they have replaced with this particular thing. Sorry, this is weather. This is the table. This is the table. Now observe this one. So what we are trying to do, we are in our class database and then public schema. We are trying to create a table. So this one, so daily 14 total. So this one we are using here, we are using a block method. We are using block method or soro method. So now when we are using this block method here, observe this. So from this particular actual table is available in this particular database in this schema. So this is the actual table. So what is the volume of the data? 37.4 GB. For this particular table, we are creating a sample. Observe this keyword sample and then observe the method. So we are using system method. System or block both are same. System method. And 3 we have mentioned, right? This 3 is the probability. It means when you mention 3 here, the whatever the volume of the data we have here, in this volume, 3% of the data it is going to pick, and it will pick from each and every probability. All the probabilities it will randomly it will pick from the, so all the rows, and it will create a sample. So till here, okay, this is fine. But why we are mentioning seed 82 here? Seed 82 means this is to identify the every time the same sample. If you want to pick, when you are running this, it will pick some sample randomly from your database, right, from your table. When it is picking, let's assume that you have tested, so by using this sample, and then so once the query is done, so once the data is created, then again, so your manager or business user came to you and then they asked, can you give me the same sample, so whatever you have tested, same sample of the data whatever you have tested. I need to create another table, and then I have to so build some queries on that. Then so you have a table, that is fine. But you don't, you when you create another sample, again it will create randomly, it will create a new set of data. Instead of creating new set of data every time, if you mention seed this some number, this number it's a random number, you can mention. So let me show you, so what is this, so what the seed value here, if you observe in Snowflake documentation, seed, somewhere it will be there. Now observe this one. So you can, it can be an integer number in between 0 to this number. So till this number you can mention any number. So when you are mentioning this particular number, again, when you mention the same seed, if I mention for when I am creating another sample, if I mention the same seed again, then it will pick the same sample again. It will not be the new set of data. So that's why if you want, so you can mention seed 82 seed. So not only 82, you can mention any number. So because 82 I have taken because of the uh, in like when I am taking this, so we have some same documentation, so I have the same number, that's why so I given the same number. You can mention anything here. So when you mention any number here, if you mention the same number again when you are creating another new set of sample data, then it will create the same set of data. That's why we will mention seed, otherwise it is not required. Now let's observe this, how it is going to create a sample data. We are creating a sample data here now. So now from this particular data, we are creating a sample data in our class and then public schema. So let it create. It will take some time. So what is the volume of the data here? So we have in this table 37 GB, right? Around so 38 GB, let's consider. And then we have around so 90, so 9 crores 10 lakhs records it seems. Okay, so let's run this. And at the same time, so this is, we are using a system method, right? We mentioned the probability 3. So let's see how much time it is going to take. The same thing, so we will use, so for, so another method, this is block method we are using. So let's take for the another method also the same thing we can use. So instead of row method, use here row. You can give the any name here, and then sample. Instead of the system here, we are mentioning row. We are mention row. This is a row method. So this system method, it is going to pick based on partitions, based on number of partitions. This is going to pick based on number of records, number of rows. Randomly, it is going to pick. When you are doing this, if you have huge volume of the data, we will use this so method. So system method. So when you have less volume of the data, we can use this. If you observe here in the both the samples, okay, so this is one sample data we are trying to create. It is creating now. So the table here also we are creating a sample of the data. This is another table. Now this is created. How much time it has taken? 1 minute 56 seconds, right? 1 minute 56 seconds it has taken. And if you observe, refresh it here, and let's come to this. See this one. So what is the volume of the data? If you observe, see this one, around nearly, so 3% of the data in 37 GB, right? So around 950 3 so MB. And then observe the number of records, it 3%. So from that particular, the volume of the data, so right, so this is nearly, it is going to pick the, so 3%. So this is a based on partition it is going to create in the backend. Now the sample data is available. So instead of running the queries on this particular table, so what we can do is we can run the queries. So for the reporting purpose, if anyone asks, we can give this sample data to them. So when they are perfect with the data, so then only, so we can give the access to this particular thing. So then what will happen? So your development time will be reduced, and at the same time the processing time, the cost, so you are going to reduce. So that is the one of the, so best practices. So we are going to, so create, so when you are working with a sample data, when you are giving the access to the reporting purpose, this all these things we will control that. Now let's observe this. This is a row method, another one. Again you are mentioning the same sample 3, same sample 3 we are mentioning. When you mentioning same sample 3 here, again this, to just to compare, so how much time it is going to take, how much time it is going to take. So again we are taking seed 82. So when you give again seed 82, when you created this sample, it will remember this seed 82. It means the same sample set of the data it will remember. Again when you are giving seed 82, it will pick the same set of data, same set of data, almost near to the same set of data. Now when you are running this, and you can use any one of the method. Let's see how much time it is going to take. Almost this one also it will create a, so the nearly 3% of the data from your, the huge volume of this particular data. So this is the
Will
sample. Yeah.
will this occupy storage, or it will, it will act like the
uh,
cloning thing which we have
mm,
discussed?
when it is coming to that, yeah, if you observe this, right, so if you want to clone, you can clone it here, or you can create it. If you want the permanent, you can give it as a transient table. So you can clone also this one instead of, so here what you are doing, we are using a create table as we are using, right? So I don't want to create another table, we don't want to another storage. What we can use is, so here instead of this one, so just you can use clone from, you can use a clone option here. So both the things, it's up to us. So if you don't want to occupy the storage, you can use a clone option. So if you want occupy the storage, so then, so you can use a, so transient table. So but so you should not use a permanent, so because so it will occupy a your fail safe. Again it will be a, the storage, so this will be there for the permanent tables, right? That's why we can use a transient tables instead of permanent tables, or you can use clone also, it's up to us. Okay, so but when you create a transient table, so definitely it will occupy a storage. So here we are creating a transient tables. If you observe, this is this one, we are creating a transient tables. These transient tables will occupy a storage here. Okay, now, so let's come to this, let it run. So how much time it is going to take, so we'll see that. And if you observe the samples here, now observe this one. See this, if you create a sample like this, sample 10, if you give sample 10 here, when you created a table, see this one, 10% of the probability. So within the bracket, whatever you are mentioning, right, that depends on the probability. Here we are not mentioning a seed, seed is a optional. So if you want the same sample again and again, so for the so to remember, then we can give a seed number, otherwise it is not required. So if you mention 20.3, so when we are creating a method, the so Bernoulli method here you are using, so 20.3 means 20.3 probability being included in the sample data. The row has a 20.3%. If you mention 100%, all the records will be included in the table. If you mention 0, so nothing, it's a empty table, right? So when you are joining also, so it depends. So you can mention the probability of the percentage when you are creating a sample. So this is the main intention of the sample here. So let it run. So after that we will see that how much time it is going to take. And what is the advantage here? Okay, now observe this one. Development life cycle will be so very quick. So instead of, if you observe here, so it is taking some time. So when you fire any query on this particular table, and when you are firing a query on this table, so definitely it will reduce the time, right? So let's assume that, so when you are fetching any data from this table, if it is taking 10 minutes, so when you are fetching so the data from this particular sample table, it may take so 2 to 3 minutes, right? Then we are saving the time. At the same time, so we are saving the cost also, so for the processing time. So that's why, so development life cycle will be quick. And so we can test all the possible scenarios up to 80% accuracy. Why they are giving 80% accuracy on the sample data? Because even though it is picking all the possibilities of the records, but it is, we cannot so tell that so this is the complete data, right? This is still, it is a sample data only. This is not the complete data from your actual table. That's why, so we can say that 80% of the accuracy. So once the 80% of the accuracy, once they reached, so like let's say they have created a table, on the table they have generated a reports, and then business user is satisfied so with that particular report, so whatever so they are expected, it is available there, then they can run the queries on the actual table, and it will reduce development cost because of the processing time. Analytics team, so if they test their queries on the sample data like reporting, so to whom we are sending the reports, right? So if they so happy with the data, then so we can run the execute the queries on the actual database. So this is the main intention behind creating a sample. So most of the thing, so generally, so if they like anyone, when they are coming and then so reporting as if they want to access any data, then so instead of giving the actual so table, so the huge volume of the data, we will create a sample, and then we will give the sample data table access to the those guys. That is the main intention behind the creating a sample. So you can mention anything, you can see that these are the so other examples, so how to so mention the sample. So see this one, so seed 82, right? You can mention the seed, or you can mention repeatable. This is also another keyword for the seed. You can mention anything here. So you can, so this is a seed or repeatable are both the same thing. Repeatable means the same set of data again it is going to take like a seed. Okay, so that is a let's let it let it run. So just see this one, so we can observe here itself. So this one, so this is so created a sample based on a partition. This is creating based on number of records. So this one to create the table, so by using the same sample and same set of probability, it has taken 1 minute 56 seconds only. But here still it is running 6 minutes 26 seconds, it is gone, still it is running. So maybe it will so finish in another 1 or 2 minutes. So this so method is taking so huge time, right? So when you are mentioning, so if it is huge volume of the data, then we can go for this system method. So this system method, or so we can call it as a block method. So this is based on so backend partitions, this is based on so number of records. Only the thing is, so the difference is so the execution time, so to create a table. So generally, so here when you are mentioning the sample, so you can mention so based on So probability, if you mention here, so instead of 3, if you mention 50, 50% of the volume of the data from this particular table, here around 37 GB we have, so it's nearly 50%. So around, so uh, 17 GB, or so around nearly 17 GB of the data it will be created. So in the sample data, that is the main intention of sample. Let it create, it will take some time. Okay, then so what we'll do is, so we'll discuss about, okay, best practices. Okay, best practice and materialized use. We'll do one thing, so I will stop it here. Okay, so we'll continue that um, best practices and then materialize you in the so next session. Okay, uh, now it's completed. Now observe this, how much time it has taken. 8 minutes 1 second. Now which one is the faster? So our system method is the faster when you created a table. Now observe this, nearly the same volume of the data will be available in the both the tables. See this one here, it is taken 1.2 GB, and then here nearly 1 GB, right? And then here around, so these many records, around 26 lakhs. So here around 27 lakhs, nearly the same volume of the data. So nearly 3% of the data it has picked from your base table, right? So both are, you can use any one, so particular sample, so for the sample purpose. So this one, so it gives the probability. So what is the probability of the data it has so picking from the so table? So what is the probability of each and every row, so picking from the so original table? So that is the sampling. Okay, so any questions here?
Dinesh, what is the base
Yeah,
difference between the system and this row? So why you are using that one?
which one? So this one
The
and this one. Okay,
system and
in
row.
the back end what it will do,
Mhm.
yeah, when it is creating system method, so it is going to pick the sample based on number of partitions. So what it will do, so when the table, the data it is stored in the actual table, it is going to create a partitions, and then it will store the data in the backend in the form of partitions, right? This one, when you are using system method, it will pick the values, it will pick the data from each and every partition. But when you are mentioning a row, right, so how many number of rows we have here, so it will not go based on the partitions, it will go and then pick based on the number of rows. Randomly it will pick from the number of rows. So that is the main difference. That's why it is taking less time, it is taking more time.
So randomly it will go, but it
Exactly.
won't go on sequence.
No,
Okay.
it won't go on sequence.
So that's the reason it is taking much time.
Exactly.
Yes. I'm getting. I got it.
Okay. Any other questions from anyone?
Why so long time in the system thing?
Uh, Coming to that, Kumar, so here when you are using the, so this particular so method, right? So here what it is doing, it is picking based on number of records, not the number of partitions. Always number of partitions will be less, right? That's why it is taking less time, and then this is taking more time.
But as we have already collected that
Mm,
seed 82 data, so I
mm,
think
mm,
the most of the thing would be taken from that 82, and
mm,
the
mm,
difference would have been taken from the row side, right? But again, 8 minutes
mm,
is
mm,
in comparison
mm.
of 1 minute, 2 minutes, it is too high.
No. So this one, so it will go so based on each and every row, so not based on the partition. And when you mention seed 82, right, the same set of data, it will make sure that whatever the seed 82 data available here, so it is also this sample also, it is make sure that the same set of data available here in this particular sample also. That's why it will go and search for the same sample set of the data, and then it will pick all the records. it's completely, the algorithm will run in the backend and then it will pick randomly. Nothing to do so anything from our side. Okay.
So Dinesh, are you going to cover that snow site because I just explored
Yeah,
that snow
I will
site.
tell you. Snow site, we will discuss that in the next sessions. It's a very simple concept. So what they are trying to do is this snow site. So let me show you this one. Okay, the Snowflake. So what they are trying to in the so near future, the complete reporting purpose also they are trying to build so within our Snowflake. So they are trying to get hold on reporting solution also, but still they are developing this. The snow site, if you click on this particular thing, so now it is directing to this one. Let me log in. It will give you the insights of the data in that particular table. So it means, let me show you here. Log into account admin. For example, if you come to the worksheets, let's create a data here. Let me show you somewhere anything. Somewhere we can able to create a, okay. Now let's observe this. For example, let's take any data from this tables. This call center or catalog page, catalog return. Oh, so when you run this, now observe this one. So it is going to give the high level statistics for the analytics team. So if you observe here, so we have the data here. Generally, when you run the query here, so what you can able to see, select, for example, start from. So this is the table, call center table, right? So our preview data, you can able to see the data. So generally we can able to see the data here. That's it. But we cannot able to see any statistics related to these particular columns, right? So now if you observe here, see this one, it is giving statistics for each and every column here. If you observe, it is telling that 16 number of records. So call center SK, so this one, so this is, so the column, and then this is the data here. They are telling that in between 1 to 60. So the so call center SK thing. And the dates, if you observe in between, so these dates from here to here. So and at the same time, so this open date, so if you mention, so this is some number in between these numbers. So just it is showing the statistic. If you observe here, so name, so North Middle East we have 3 records, and then so Hawaii, so we have 3, and then so North Middle East we have again 3, and then so like this it is showing for each and every column the statistics it is showing here. So this, so this the future they have given so in this no site, but near like a future, so the what they are trying to do is, so generally for reporting purpose in any warehousing, so maybe you will use Power BI or Table U or ClickU, whatever it may be, right? So instead of using some other tool, the Snowflake is trying to build the complete reporting like a futures in our Snowflake. So they are so still so working on this particular the snow site, so for the reporting purpose, the at this point of time, so we can able to see only the statistics here, and then we can so display the so dashboards, so like this, so just so for the analytics team purpose. So that is the snow site here, but it is so not completely developed still, so they are working on that.
Thanks.
Then so we have another feature called data marketplace. So this is also we will discuss in the next session. So what is this data marketplace, what we can get it from the data marketplace. So this is very useful. So maybe you heard about metadata management in between, so sister companies, right? So how to get the data from the sister companies very easily instead of creating from the scratch. So we can go for the data marketplace, and we will see that. So I will show you in the next session how to work with the data marketplace.
Dinesh, I have a quick question for you.
Yeah, Priya, tell me.
So, Snowflake obviously is a database where it can store data,
Mm,
right? Which
mm, mm.
ETL tool is really popular right now for Snowflake combination
Okay,
in the
so coming
market?
to that, so if you observe the Snowflake has suggested, so in the partner connects, if you observe this, Matillion, see this one, Matillion, right? This is the ETL tool. This is the free open source tool. So the Snowflake and then Matillion combination they are using. We have some other tools also, like if you observe the talent we can use, stage stream we can use, and then Informatica also use, but there is some limitations in between Informatica and then when it is coming to talent, so limited data here. And then here when they are using Informatica, if it is more than 1 billion rows per month, then so you have to purchase Informatica license. That's why everyone will go for some Matillion. Matillion is the popular ETL tool for the Snowflake combination.
Thank you.
Yeah.
And I still miss this point about structured and unstructured data. So
Mhm.
Snowflake can handle only structured data.
No, it's not like that. We can handle unstructured data also.
So if it can
So
handle unstructured data, right, in the big data world, like you have Hadoop,
semi-structured. Kind of
semi-structured.
semi-structured. Yeah, we cannot say that it's completely the unstructured data.
Mhm,
Unstructured data means some video recording, some like a pics data. So all these things we can call it as unstructured data, right? Here
mhm.
the Snowflake handles semi-structured data, like kind of we saw that, right? JSON files handling, Pocket
JSON
files
files
handling.
and all is
Yeah,
semi-structured.
these are
Okay.
the semi-structured data it will handle.
So, you have Hadoop and you have all these big data things, right? How does Snowflake
Mhm.
win over those guys like Hadoop and all those?
Mm-mm. So when it is coming to Hadoop and all those things, they can able to handle the unstructured data also. But here it is not possible. When it is coming to Snowflake, we need to keep it in a semi-structured format. Then only we can able to handle.
Yeah, one thing is I'm just want to understand the storage concept. Like that,
Mm-hmm.
in Windows machine, if we say that it is 64-bit machine, then a block
Mm-hmm.
size is of 64-bit, right? When I
Mm-hmm.
come to Hadoop, it says that the block size would be minimum 1 MB.
Mm-hmm.
So in same way, it is storing in the partition of 50 MB, a minimum
Mm-hmm.
of 50 MB, right? So
Mm-hmm.
that 50 MB
It
is the
is.
block size they are using, right?
It's a compressed one, 16 MB.
16 MB, right? So,
Yeah,
my
uncompressed
question
50
is,
to 500 MB.
if I think
Mm,
about Oracle, so
mm,
if a record is stored in multiple blocks, multiple OS
mm-hmm.
blocks, Oracle say them,
Mm-hmm.
it's a chained block,
Okay.
right?
Mm-hmm.
Is called block chaining. When I come to here, then the block size is
Mm-hmm.
again 64-bit at the operating system side. But when it is
No, no.
storing
So
at
this
big
is
data and
completely. It
on,
is not. Yeah, yeah. Coming to this, Kumar, it is not storing in any physical storage, right? It's completely in a cloud,
right? So then cloud is
right?
a go again on any
Mm,
of
mm,
the
mm.
OS, on the OS. It is
Maybe.
Linux or
Mm.
anything.
Yes,
So
true. That is
how
true.
can the block size would be 16 MB, and so that I don't think any
Mm,
operating system is providing such a big size of block.
mm, mm, mm,
So how it
mm,
is being managed there? It
mm-hmm.
is confusing me every
Understand.
time when I
Okay, okay. Understand your question. So I will get back to you on this. I'm not sure about this. Okay, how the things will
Mhm.
run in the back end. I will check on this. I understand your
Oh,
question, Kumar.
okay, okay. I think this is more related to cloud, But I just want to
Yep,
understand if
exactly.
because we are dealing with
Mhm.
the data, right?
Correct. I will check in some documentation. So if any link is there for related to the storage and then block sizing, I will inform you. Okay.
Okay. Okay.
Okay, guys. See you tomorrow. Thank you.
Thank you.
Hope you feel better. Thank you.
Yeah, thank you. Yeah.